Welcome to the fourth module of Economics and Management. This PPT has been prepared exclusively for the purpose of the education and benefit of students. I do not claim any originality in preparing this, and I thank everyone who have helped me in this preparing this PPT. In this module, we will discuss about the comparison of alternatives. Normally, any engineer, a manager will face this particular problem in an industrial scenario. There will be different alternatives available, and as a manager, you need to choose the most optimum among them. And what are the different bases for selection of these alternatives? Based on what we compare and then select, those points will be discussed in this particular module. There are four methods of comparison: present worth, future worth, annual worth, and internal rate of return. So in the first method of comparison, we normally go with the present worth comparison of methods. In this present worth of comparison of alternatives, we compare the alternatives based on the present worth. In other words, what we do is that we convert every cash flow into their present worth. Present worth 1, present worth 2, present worth 3, like that, depending on the number of alternatives. And we select that particular present worth which gives me the best result. If I end up with a positive answer, I go with the present worth that gives me the highest value. If I end up with the cost, I go with that particular alternative which yields the least cost. That's how I select the most optimum alternative. The same methodology is followed in annual worth comparison of alternatives, wherein every cash flow is converted into its uniform flow of cash. Here, every cash, irrespective of its type of flow, is converted into its A, and then alternatives are compared. The same methodology of that yields the best will be selected here. In future worth comparison of alternatives, the logic is the same. I compare different alternatives based on their future worth. So I convert every cash flow into F and then compare the alternatives. In rate of return, I go with two methods: internal rate of return and external rate of return, and I calculate the IRR that I obtain by following different alternatives, and that particular alternative which gives me the best rate of return will be selected. Let us start with present worth comparison of alternatives. There are certain conditions to be satisfied. We need to assume some assumptions, we need to make some assumptions before we proceed further. The first assumption is that the cash flows are known. Cash flows are known means there is no ambiguity in the cash flow. That means the revenues or the costs, they are very clear and they are known to us. There is no probability of flow, nothing like that. So it is very clear that whatever it is, a cost or a revenue, whatever it is known and there is no ambiguity with it. Second assumption is that cash flows are in constant value rupees. Constant value rupees in the sense, normally what happens over a period of time, the purchasing power of any currency will vary. This we have already discussed in our earlier module, and the main uh, reason why the purchasing power of the currency changes is the inflation. But when I'm comparing the alternatives based on their present worth, the inflation is not considered. So inflation rate is neglected when I'm comparing the alternatives based on the present worth. The third assumption is the interest rate is known. Interest rate is known means the interest rate between two periods of time is constant and it won't vary over a period of time. Throughout the cash flow, between two periods, say between first and the second year, the interest rate is fixed. It may change later, but it is not that within a year the interest rate will keep on changing every moment, every day like that. That is the meaning of interest rate is known. Next assumption is comparisons are made with before tax cash flows. So the alternatives, whatever we are considering, we stick on to the costs and benefits, or the revenues and the payments that are involved with respect to those particular alternatives. The tax involved are not a part of this present worth comparison of alternatives. So any cash flow that is happening, they are all before tax payments. Fifth assumption or the fifth condition is comparisons do not include intangible considerations. This is a very important factor or assumption. For example, some of the alternatives, even though they yield lesser, when it comes to other factors such as attraction, uh, satisfaction, these factors are immeasurable, intangible. So I am not supposed to include such intangible factors while comparing two alternatives. That is the fifth assumption. The last assumption is comparisons do not include consideration of the availability of funds to implement alternatives. The comparison of alternatives is done exclusively on the investment made for that particular alternative and the revenues obtained from those alternatives. The funds that are available to start the alternative is not a part of this comparison. That is another important thing. That is required because some of the projects may have a better funding and some of the projects may not have that much of funding. The initial funding is not a factor to be considered for present worth comparison. Only the expenditure involved or the investment involved in starting that project and the revenues that are obtained from those alternatives are a part of present worth comparison of alternatives. In present worth comparison of alternatives, normally we follow two methods. First method is present worth equivalence and the second one is net present worth. Present worth equivalence indicates any future cash flow, whether it is uniform series or single payment, they are all discounted to their present worth. Which means I am converting every cash flow to its present worth at t is equal to 0 or at time is equal to 0 or what we normally call it as today. So and the net equivalent amount of the entire cash flow will be calculated at t is equal to 0 and based on the final result what I get, I take the decision. Second method is net present worth, wherein I calculate the present worth of benefits and the present worth of costs. Costs are obviously negative. I take the arithmetic sum, present worth of my benefits minus present worth of costs, and based on the results what I get, if the benefits are more, then I select that particular alternatives. If all of them end up with costs, I select that particular alternative which gives me the least cost or the least burden. Thus, I make the selection using net present worth. Uh, that's what is explained in this. Till now we have discussed about various conditions of present worth, comparison of alternatives, and methods of solving the problem. Okay, let us take up a first example. There are two alternatives for purchasing a concrete mixer. Both the alternatives have same useful life. The cash flow details of the alternatives are as follows. Compare the assets based on their present worth at I is equal to 10%. The rate of interest is given as 10%. The first alternative has an initial purchase cost of rupees 3 lakhs, annual operating and maintenance cost of rupees 20,000, and the expected salvage value of rupees 1,25,000. The useful life is already given as 5 years. Okay. Before you start any problem, I have been telling you that first identify whether that particular cash flow given is A or P or F. That will help you to establish the relationship and identify the which factor that must be used. So let us go one by one. First we have initial purchase cost of rupees 3 lakh. What is this 3 lakh? Initial purchase cost. Initial means what? Now. And obviously it has to be P. Next is annual operating cost. What is annual operating cost? The word itself is very, very clear. Annual means A. So this 20,000 is A. Expected salvage value. What is salvage value? This is a new word to you. Salvage value means that is the resale value. When do we make the resale? We make the resale at the end of the asset. That means when the asset ends its life, it will have some useful worth in it. That is a salvage value or the scrap value. See, we take a bike after some years when we do not want to use it and it is not worth using it, we scrap it. And what is that scrap value? That is nothing but your salvage value. And when do we do that? When do we get that salvage value? Only at the end of the useful life of the asset. So where does this occur? It occurs at its end of the life, that is at t is equal to 5. So what it should be? It should be F. So let us indicate it. P is equal to 3 lakh, A is equal to 20,000, S is equal to 1,25,000, and N is equal to 5 years, I is equal to 10,000. Okay. Now let us start the cash flow diagram. First, what you need to do, you need to identify the timeline. Draw the horizontal line. Useful life is 5 years. Draw that 5 years on the horizontal line. And first indicate the P. Where will that P be situated? At t is equal to 0, obviously, because it is initial purchase. So I am purchasing that initially. So at t is equal to 0. Since I am purchasing that at t is equal to 0, it will be at t is equal to 0. Since I am paying that, it is negative. Okay. And then annual operating and maintenance cost. It is cost. Cost means what? Obviously negative. So how will it appear? It appears as A will appear as negative 20,000. 1, 2, 3, 4, 5. 5 cash flows are. They are all year-end payments. Please remember that. Unless or otherwise they specify it as beginning of the year, it is always end of the year payment. Okay. Next, which is remaining? P is over, A is over. Yes, salvage value. I have already said where it should appear. It should appear at the end. Means at t is equal to 5. What is that salvage value? We get that amount. When I sell the asset, I get that amount and hence it is positive. So I have very clearly indicated P at t is equal to 0 as negative and A as negative because it is cost, and S as positive because I earn that money at the end of 5 years. Let us solve it now. Now what is required is every cash flow must be converted into its P. Okay, let us do that. What is the net present worth 1 minus P? This is what is there. This is minus P. Next A into, that should be converted, because it is A, it should be converted into P, comma I, comma N, plus S. S is a future flow, future amount. So I use the factor P by F, comma I, comma N. Why I have not converted this P? Because please remember, it is already P. What is that I am doing? I am converting every cash flow into its present worth. What is this 3 lakh rupees? It is already present worth. Is there any need to convert it any further? Not at all. It looks uh, silly if I say that P should be converted into P. So P will remain as P, whereas A should be converted into P using the factor P by A comma I comma N. So I am converting A into P, and then S. S is a future amount, F. So F should be converted into its P. So indicate the values there. NP1 is equal to minus 3 lakh minus 20,000 into P by A comma 10 comma 5. Why 5 here? Every time I have told you, whenever A comes into picture, just count the number of flows of A. How many flows of A are there? 1, 2, 3, 4, 5. 5 flows are there. So N will be 5. And then salvage value plus 1,25,000. P by F comma 10 comma 5. How far is it from 0? It is 1, 2, 3, 4, 5 years away from T is equal to 0, and hence N is equal to 5. Get the values from the factor tables. Substitute those values and you will get the answer as minus 2,98,207. It is cost. It is cost because it is negative. Okay. Now we shall calculate the net present worth of the alternative 2. What is that alternative 2 has? Initial purchase cost of 2 lakh rupees, annual operating and maintenance cost of rupees 35,000, expected salvage value of rupees 70,000, and a useful life of 5 years, because they have common useful life. Useful life is same. First again same procedure. Initial purchase cost means what? P 2 lakh, annual operating cost 35,000 A, and a salvage value yes 70,000. Whatever the explanation we had for the first alternative holds good here as well. Let us start with the cash flow diagram. First draw the timeline. Here also timeline is 5 years only. And where will P appear? P will appear at T is equal to 0. Draw that first. 2 lakh rupees. Where will A appear? A appears starting from first year for 5 years. Indicate that. That is also cost because it is annual operating cost. Annual means every year. Now which is the P is over, A is over. Which is remaining? S is remaining. What is that? S, salvage value. What is that? When we sell it, we get that. So it's a positive flow. Where will it appear? At T is equal to 5. Indicate that. So your cash flow diagram is ready. Now let us solve the problem. NPW2. NPW2 is equal to P minus A into same procedure what we followed for the first alternative. Minus P minus A into P by A comma I comma N. This 2 lakh will remain as 2 lakh because there is no further conversion required because it is already P. Okay. So A that must be converted into P. This is S which is F future sum. So that must be converted into P. So first let us convert this A into P using the factor P by A comma 10 comma 5. Here again you count the number of flows. Whenever A comes into picture, don't hesitate to count the number of flows. 1, 2, 3, 4, 5. 5 flows are there. So N will be 5 plus 70,000. So what is the 70,000? That is F. F must be converted into P. Where is F? This F situated at a distance of 5 years. So 1, 2, 3, 4, 5. Substitute N as 5. So this will convert every cash flow, that is A into P at T is equal to 0, and this F 70,000 F to P at T is equal to 0. So what will be the answer? Substitute the values from the factor tables and the answer is 289222. Again this is cost, you get it as negative. Whenever you end up the answer as negative, you indicate it as a cost. Okay. So now what is your conclusion? Your conclusion also carries 1 or 2 marks. Please remember that. If you stop at this stage, you will lose that one valuable mark. So now write the conclusion. Based on the net present worth of two alternatives, what do we find? Since the cost of alternative 2 is lesser than the alternative 1. Alternative 1 had minus 298,207, okay, which is higher, whereas here I have 289,222. So NPW is better. Burden is lesser for me. That's why I prefer the second alternative. That means the second concrete mixer is preferred over first concrete mixer. That's how, or that's what you need to conclude. We select the alternative 2. Again I say that this last sentence will give you 1 mark. If you do not write this last sentence, you will lose 1 mark. Please remember that. Let us go to next problem. I have an alternative whose initial purchase cost is rupees 3 lakh, annual operating and maintenance cost of 20,000, annual income of rupees 50,000 per year, and the expected salvage value of 1,25,000, useful life of 3 years. This is similar to your earlier problem with only one additional factor of this annual income of rupees 50,000 per year. How does it appear? What is this annual income means? Is it positive or negative? Income, word itself is very clear. Income, positive. Revenue, income, they are all the positive flows. That's what we need to identify. What is that annual income? Annual, very clear, it is A. Let us indicate them. Okay. Alternative 2 has the same thing, except for that the annual income is rupees 45,000 per year. That is the difference between this problem and the earlier problem. Compare the alternatives based on the same thing, 10% rate of interest, and find out which alternative is better. In the first problem, alternative 2 was better because it yielded me lesser cost. Let us see, when I add the income factor into this problem, will the decision change or it will remain the same? Let us see that. First draw the cash flow diagram. Same, there is no difference here, much difference, because only difference is this one. The annual income has been added over here. A, every year it should flow, income positive flow, put it above the horizontal line. Calculate, do the calculations. Minus 3 lakhs minus that's already P, there is no need for further conversion. This 20,000, this 20,000 is A, convert that into P using the factor P by A. Then this 50,000, that is also A, use the factor P by A comma I comma N, convert that A into P, and then last one 1,25,000, that is at a later stage, later time. Obviously it is single payment and hence it has to be F, convert that F into P. Substitute the values properly, that is 3 lakh, P by A comma 10 comma 5, P by A comma 10 comma 5. Whenever A comes into picture, I have always mentioned, literally count the number of flows. In each of these I have 5 flows, so N will be 5, and this 1,25,000 is at a distance of 5 years from now, or at t is equal to 0, and hence N will be 5. Substitute the values from the factor table and you get the answer as minus 1,08,663. Now let us draw the cash flow diagram of the alternative 2. How does it appear? It appears almost the same way, except the income factor of rupees 45,000 that has come above the horizontal line because it's a positive flow. That also flows for all 5 years. They are all year end payments, remember that. And one more point I would like to mention here is that See, whenever I mention it as year-end payment or year-end revenue, remember that cost or revenue do not occur only on that particular day. Say for example, December 31st is the last day of the year. It is not that it occurs exactly on the December 31st. It is the accumulated amount starting from January 1st till December 31st, but I represent that on the year end. That's all. It is not that there was no cost starting from January 1st to till December 30th and only that cost appeared only on December 31st. No, it is wrong. It is the accumulated cost which I represent it on December 31st or the year end, and it is the accumulated income or the revenue which I represent it at the year end on the December 31st or year end. Okay, let us calculate for the alternative 2. Minus 2 lakh, it is already P, there is no need to convert it further. Minus 35,000, it is A, convert that into P. 45,000, again it is A, convert that into P using the factor P by A. 70,000, that is F, convert that into P using the factor P by F. Substitute the values of I and N, substitute the values from the factor tables, and we get the answer as 118629. It is again cost because it is negative. Now, which is better? PW1 yields a cost of 1,88,000 and the second alternative yields a cost of 1,18,000. So which is better? Alternative 1 is better. That's what you need to write very clearly. In this case, alternative 1 will be selected. See, our decision changed when we added the income factor. That is what an engineer should always look into. Don't jump into conclusion based on few assumptions. You have to consider all the cash flows, all the possible cash flows, and then take the decision. That's what we did here. So our decision changed because the income of alternative 1 is better than income of alternative 2. But just for the reason it is 5,000 more, you cannot conclude. You have to draw the cash flow diagram, discount it to t is equal to 0, and then get the answer. That is how you need to complete it. Okay. Let us go to next problem. A production company has 3 options to purchase an equipment for transportation and dumping of soil at a construction site. All the alternatives have the same useful life. Let us see the cash flow details. Alternate option 1's details are given. Option 2's cash flow details are also given. Option 3, there is one more option here in this problem. Its cash flow details are also given. And what we need to do is that using the present worth method, we need to find out which alternative is better at an interest rate of 8% per year or per annum. All one by one. First, let us get the first option. Initial purchase price of rupees 25 lakhs. Purchase price means what? P. Annual operating cost 45,000 A at the end of first year and increasing by rupees 3,000. So what is it now? Will it remain as A? You need to be a bit careful here. This has 2 cash components associated with it. It has a cash component of 45,000 at the end of first year that increases by rupees 3,000 in the subsequent years till the end of the useful life. What does that mean? It is not just A. It is an arithmetic gradient. So whenever you have arithmetic gradient factor, 2 cash components will appear. One for the first year, that is A1, and another for the G, gradient amount. So hence it is a gradient factor. And annual income of rupees 1,20,000, which is a positive flow, and salvage value of rupees 5,50,000. Salvage value obviously that occurs at the end of the life period. How will the cash flow diagram appear? It appears like this. See here, first 25 lakhs P. Then the annual operating cost of 45,000. First year the operating cost is 45,000. Cost is increasing. That's what you need to understand. Okay, cost is increasing. So below the horizontal line only you have to represent that, because it is cost negative. So first year it is 45,000, second year it is 48,000, and it goes on increasing like this till the end of its useful life. What is the useful life? 10 years it is given. So till 10 years it goes on increasing. And the income, what is the income? Income is annual income of rupees 1,20,000, represent that. Salvage value of 5,50,000, represent that. Your cash flow diagram is ready. Now let us solve the problem. First, put them. P is equal to 25 lakhs, A1 is equal to minus 45,000, G is equal to 3,000, A2 is equal to plus 1,20,000. What is that A2? That is the income. S is equal to 5,50,000. Let us convert everything into P. First, 25 lakhs. It is already P. There is no need for any further conversion. Retain it as it is. Next, 45,000, P by A, I, N. What is this 45,000? See, this 45,000, it is uniform throughout. See here, every year this 45,000 is constant, right? So this 45,000 can be directly converted into its P, A to P. Okay, and then this 3,000, it is G. G can be converted into P. How? P by A comma P by A multiplied by A by G. If you use two factors, P by A multiplied by A by G, A and A gets cancelled and you will get P by G. That factor is written here, P by G comma I comma N. Some of the interest factor tables will give this P by G value straight away, or else it is very simple. How did we get this P by G? Using two factors. First, P by A, that multiplied by A by G. P by A is in the denominator, multiplied by A by G, A is in the numerator. A and A gets cancelled with each other, and what do we get? We get P by G. So if you multiply these two factors, P by A and A by G, you will get P by G and multiply that by the value G. You can directly get the answer. So there is no need to convert this gradient flow into A and then to P. In order to avoid that, this is a easier method of solution. Then plus 1,25,000, it is A, convert that into P. There is no problem in it. Plus 5,50,000, it is F, because it is at a distance of 10 years from now. Convert that into P. Now let us substitute the values of I and N. I, it is annual compounding, so 8%. So whenever A comes into picture, literally count the number of flows. There are 10 number of flows, count it. See now, A 8 comma 10. Now P by G comma 8 comma 10. Should I consider 10 or 9? That is a regular confusion with every student. Remember, my dear friends, 45,000 or the A1, the first cash flow, is a part of that gradient flow. Remember that. It is not exclusive. It is included in that gradient flow. Since it is a part of that gradient flow, whatever the N value you put for A, same N value you should put for G also. There should not be any difference here. This N value and this N value, both of them should be same. Is that point clear to you? Since 45,000 or the first year flow is a part of the entire gradient flow, whatever the n value you put it for A, you use the same n value for G also. So here I have used the n value as 10 because there are 10 number of flows. So I will use the same n value 10 for P by G factor also. And 1,20,000, there is no doubt here because there are 10 number of flows. I will use n as 10. And F 10 because it is at a distance of 10 years from now. Substitute the values, get the factor values from the factor tables, substitute them, and you get the answer as minus 18,19,912. Okay. Now let us solve for the what is there in the alternative 2. Initial purchase price, everything is given. Let us convert that into cash flow diagram. What is there in the cash flow diagram? Same procedure. Initial purchase price P, represent that here first. Useful life of 10 years. Draw a horizontal line of 10 years. Represent P at T is equal to 0 as 30 lakhs. Annual operating cost of rupees 30,000. So operating cost 30,000. See here the difference between this cost and the previous cost. There I had two cost components. An annual operating cost of rupees 45,000 in the first year, which increases by rupees 3,000 was given. That means there are two cost components. Here there is only one cost component, which means it is not a gradient flow. This is a uniform flow. Annual operating cost of rupees 30,000. So that's why put it as just 30,000 uniform throughout for 10 years. Annual income of 1,50,000 for first 3 years and increase by rupees 5,000 in the subsequent years. See, first 3 years it is 5,000. 1, 2, 3. First 3 years it is 5,000. Starting from 4th year it increases by rupees 5,000 every year for the next years till it ends. That means 4th year it will be plus 5,000, 5th year plus 10,000, 6th year plus 15,000, like that it increases. And the last salvage value of rupees 8 lakh, represent that here. You can add it above the last value as 8 lakh rupees. This is in addition to this value of income. Okay. Now let us solve it. How do we solve that? First, identify them as P or A or F, which we have already done. P is equal to minus 30 lakhs. A1 is equal to 30,000. There is no doubt in it. A2 is equal to 1,50,000. 1,50,000 it is throughout. Okay, that 1,50,000 I will take it as a amount which is throughout. Okay, and G is equal to 5,000 and S is equal to 8 lakh rupees. Minus 30 lakh, it is already P. There is no need for any conversion factor. Then 30,000 rupees, which is a cost, convert that into P using the factor P by A. Then 1,50,000 is the income for the entire 10 years. Since it is uniform throughout, convert that into P. Now this, let us consider this G factor. In the previous problem, what was there? G was right from the second year. So there was no problem for me. I could substitute the value of n as 10 years straight away. But here it is not like that. You can see that here there is a gap of these 2 years. And it starts from 4th year. Okay, it doesn't start immediately from second year. There is a gap of 2 years and it starts at 4th year. How do we encounter that? Observe carefully. 5,000 P by G, 8, 8. That's what I said. See, 1, 2, 3, 4, 5, 6, 7 plus the initial one. Which is the initial one? This is the initial one at t is equal to 3. That initial flow must be considered while counting the number of n for a gradient flow. Please remember that in the previous also there were 9g plus, but plus 1 because for the initial amount. Here also the initial amount is 1,50,000. So I have to consider that one initial flow of 1,50,000 and take that value for n1. So 1, it starts from here, 1, 2, 3, 4, 5, 6, 7, 8 till 10th year. So n will be 8 and hence n is 8 here. Now when I convert this g into p, where will its p be situated? As the rule says, whenever you convert a into p, where will its a be situated? 1 year before the first payment. Same rule holds good here also. Whenever you convert g into p, its p will be situated 1 year before the first payment. When is the first payment? At t is equal to 3. Where will its p be situated? At t is equal to 2. Okay, that's what I represent it as p interim or ps or something like that. Okay, now this has to be converted into p at t is equal to 0. I have to bring it to t is equal to 0. How do I do that? Using the factor p by f. Why p by f? Because for t is equal to 0, this is a future sum. So that future sum f must be converted into p. That's why you use the factor p by f comma 8 comma 2. Why 2? Because it is at a distance of 2 years. 1, 2. It is at a distance of 2 years from now. So convert that. Okay. So this is very, very important here. One point I would like to highlight again. Whenever g comes into factor, while considering the number of years, you have to count the number of flows of g plus the initial flow. In this case, there are 7 flows of g plus the initial flow, 7 plus 1, hence n is equal to 8. It is not 7. If you make it as 7, you are wrong. You won't get any mark. Is that point clear to you? Please remember, whenever g comes into picture, count the number of flows of g plus the initial flow. In this case, there are 7 flows of g starting from 5,000 at t is equal to 4 plus the initial flow. So hence it is 7 plus 1, 8. And for this p by g factor, I put the value of n as 8. Substitute the values from the factor tables. You get the answer as minus 17,47,902. Let's come to the third alternative. Initial purchase price, everything is given. Convert that into cash flow diagram. Very clear again. Almost similar to the earlier options. Initially 27 lakhs. Annual operating cost of 35,000 for the first 5 years. See here, it is similar to your previous option, whereas wherein in the previous option the income was income increased from 4th year. Here the cost is increasing from the 6th year. That's all the difference. Okay. So annual income remains the same for all the 10 years. Cost is increasing from 6th year by an amount of rupees 2,000. So G happens from t is equal to 6. Okay. For first 5 years it is common. From 6th year it is 2,000 additional. So 6th year it would be 37,000, 39,000, like that it increases like this. Okay. Now let us solve the problem. What is the solution? First identify whether they are P or A or F. So P is equal to 27 lakh because it is the initial price. A1 is equal to 35,000 because it is uniform throughout. Okay. And G is equal to 2000. It starts from year 6. And A2, that is the annual income, that is also uniform throughout. And S is equal to 6,50,000, that occurs at the end of the 10th year. Okay. Now let us get the factors. What are the factors? Minus 27 lakhs, there is no need for any further conversion because it's already P. Okay. Next is this 35,000, that is uniform throughout. So it is A, convert that into P using the factor P by A. Then this 2000 minus 2000 because it is cost. It is gradient, convert that into P. P by G comma 8 comma. Again the same problem, same hint. How many number of flows of G are there? 6, 7, 8, 9, 10. How many are there? 5 are there. What I have told you? Number of flows of G plus the initial flow. 1, 2, 3, 4, 5 plus the initial flow means 5 plus 1, 6. Put that as 6 here. And when you convert this cash flow into P, where will its P be situated? Same rule again, 1 year before the first payment. When is the first payment? At T is equal to 5. So where will its P be situated? Its P will be situated at T is equal to 4. Okay, that is an interim P. And this interim P, call it as a PI or P1 or whatever the notation you want to give. This has to be converted into P at T is equal to 0. That's why which factor I have to use? I need to use the factor P by F because for T is equal to 0, this is a future sum, future money. F must be converted into P at T is equal to 0. That's why I use the factor P by F. P by F comma 8. How far is it situated? It is situated at a distance of 4. So P by F comma 8 comma 4. Okay. Then there is no doubt in this because there are 10 number of flows of A and this is F future sum. It occurs at a distance of 10 years from now and hence N is equal to 10. Get the factor values from table, substitute them, get the answer. You will end up as 17,09,828. Which is better? Option 3 shows the lowest negative value and hence option 3 is better. Again I am telling you this last sentence will give you 1 mark. Don't avoid that or don't forget that. Okay. So option 3 is selected for the purchase of the dump truck or the third dump truck is purchased. Till now we have been discussing assets with equal lives. Now let us discuss assets with unequal lives. Certain assumptions are made. What do you mean by assets with unequal lives? One asset will have, say, example 3 years and another asset will have, say, for example 5 years. Can I compare them as it is? No. Please remember one mantra for comparison of alternatives. Always compare cat with cat and rat with rat. And don't say that you compare the cat with the rat and say that cat is stronger than rat. It is not, it's quite obvious. There is no speciality about that. Cat is always stronger than rat, except in Tom and Jerry, wherein rat is stronger than cat. But this is not Tom and Jerry cartoon. This is comparison of alternatives and you are all managers. You need to have some seriousness, right? So whenever you are comparing two alternatives, compare cat with cat and rat with rat and say whether cat 1 is stronger than cat 2 or rat 1 is stronger than rat 2. Similarly, when I have two assets with unequal lives, one is having 3 years and another is having 5 years, they are not same. So I cannot compare them as it is. I need to make them equal. How do I make them equal? There are two methods. First method is repeatability projects method, or I repeat the projects there and make them equal. The other one is co-terminated assumption. When I use the repeatability assumption, I calculate a common multiple between the two alternatives so that they attain the same life by repeating themselves for as many number of times required so as to make them equal. Okay, and that is how we calculate. See, for example, if assets have lives of 2, 3, 4 and 6 years, what is the least common multiple between them? It's when I calculate, I get it as 12. So the first asset has 2 years of life. So in order to make it equal to 12, I have to repeat it 5 times, or total number of 6 times. Second asset is having 3 years of life. To make it 12, it has to be repeated 3 times, or there are 4 such appearances. Third asset will have 3 such appearances, and the last asset having 6 years of life will have 2 such appearances, or it will be repeated once more. Let us take an example so that it will be clear. Second co-terminated method, what is also termed as study period method. I select a study period based on, say, life of the shorter lived alternative, or the longer lived alternative, or the shortest alternative life, or the longest alternative life, or in between shorter and longest life. See, for example, if the asset is getting terminated at the end of 6 years and another is getting terminated at the end of 3 years, I can choose either 3 or 6 or 4 or 2 based on my preference. Okay, this is a very vague method, normally not recommended highly, but still this is one method. Okay, comparison of alternatives with unequal lives. An industry has decided to purchase a machine to be employed at a production site. Two different companies manufacture the machine that will fulfill the functional requirements. Let us see the cash flows of each of both the alternatives. Machine A, initial purchase cost, everything is given. Let us not waste our time in reading those things. Let us jump into the problem. What is that? Compare the alternatives at the interest rate of 7 per year. What is the difference here? Alternative A has a useful life of 6 years and alternative B has a useful life of 12 years. This is the difference between this problem and the earlier problems. Okay, this is a case of unequal lives. How do I do that? Okay, first what I need to do, first step, you need to get the common multiple between 6 and 12. So what is the common multiple? LCM between 6 and 12, it's obviously 12. Okay, so first keep it with you. Now the least common multiple between two alternatives is 12 years. What does that mean? I have to make every alternative equal to 12. As a result, what happens? One is cat and the another one is rat now. Now what I have to make? I have to make both of them cat or both of them rat. How? By taking the LCM. So I will convert both of them having common life of 12 years, so that They are same now and can be compared. Okay. What is the first alternative? Let us convert that into cash flow diagram. Initial purchase cost of 30 lakh 50,000, annual operating cost of 40,000 at the end of first year, increasing by 2,000. So again, see here friends, it has two components. In annual operating cost of 40,000 at the end of first year, increasing by 2,000 means again it is a gradient factor. Okay. Whereas in this say annual income of 5,60,000, that means there is only one cost component, that means it is just A. Whereas the first one, it is not just A, it is A and G. Expected salvage value of so much and useful life of 6 years. Since it is useful life of 6 years, I have to convert it into useful life of 12 years by repeating it. How do I repeat that? Carefully observe. See here, first draw the cash flow diagram of for 6 years first. How? 30 lakh 50,000 at t is equal to 0. First draw up to 6 years. Okay. Operating cost of 40,000 in the first year represent that, which increases by rupees 2,000 for next 6 years. 2,000, 42, 44, 46, 48, 50,000. Just for the moment, stop here. And then an income of 5,60,000 represent that also till 6th year. Okay, first let us draw up to 6th year, and then I will tell you how to repeat it. And an expected salvage value of 10,50,000 represent that also, 10,50,000. Now the question of repeating. How do I repeat? Repeated projects method. It is like that. Now this asset was working up to 6th year, December 31st, 12 o'clock, midnight 12 o'clock. The asset was working, the machine was working, and it stopped at 12 o'clock, and immediately it is replaced by another machine. When the first machine stops working, the second machine starts working. It is like that. First machine stops working, second machine starts working. Where I should invest that? I should invest that exactly when the first machine stops working. When does it stops working? It stops working at t is equal to 6. When should I start the next machine? I should exactly start at t is equal to 6 only, not at t is equal to 7. If you make it at t is equal to 7, then the question would be, what were you doing from 6 to 7? Were you idle? You should not be. You should not be idle. So you should immediately start at t is equal to 6. So when does the second machine start working? The second machine starts its work exactly at t is equal to 6. So repeat that. What do you mean by repeating? I am reinvesting. How much? By investing rupees 30,50,000. Include that at t is equal to 6. 30,50,000. And once you start that machine, what will happen? Its cost, its income, its salvage value, everything is repeated. It is as good as copy, paste. When are you pasting? You are pasting exactly at t is equal to 6. This t is equal to 6 will become t is equal to 0 for the second machine. Copy the first cash flow diagram and paste it at exactly t is equal to 6, and this is how it appears. See here, is it not the replica of the same, the second half? Is it not the replica of the first? It is exactly the same. That is what we mean by repeated projects method. Okay. Now let us solve it. First identify what it is. Okay, same cash flow diagram, I have borrowed it. So PWA, that is present worth of the first alternative A or alternative A, 30,50,000, that is the first one. Let us take one by one. This 30 lakh, this is the first one, 30,50,000. It is already P, retain it as P. Next 40,000, which is this 40,000, this 40,000. P by A, comma 7, comma 12. Can I put it for 12 or should I put it for 6? That is another confusion with most of the students. This 40,000, it is repeating, it is flowing on first year, second year, third year, fourth year, fifth year, sixth year. Does it flow on the seventh year also? Yes. Eighth year? Yes. Ninth year? Yes. 10th? Yes. 11th? Yes. 12th? Yes. Which means 40,000 is flowing all through 12 years. Right? So can't I put N as 12 here? Definitely yes. Since this 40,000 flows continuously for 12 years, I need not have to consider it as two different projects. I can straight away substitute it as 12. Okay. So this 40,000 is over. Now let us come to this 2000 G. 2000 P by G. Convert that G into P. 7 comma. Again same question. How many flows of G are there? It starts from second year. 1, 2, 3, 4, 5 plus the initial flow. 5 plus 1, 6. Hence N is equal to 6. P by G comma 7 comma 6. What did this factor do? This factor converted this G, which is this G, it is this 2000, that is the 2000 of the first cycle. Okay, where is the first cycle? Here is the first cycle. This is the G of first cycle that has been converted into P. So that is done. Then next is 5,60,000. Which is that 5,60,000? That is the salvage. No, that is the income, annual income. How is it flowing? 1 to 6 years it is flowing. Once we repeat that, again what will happen? It will start repeating. So 6th year it is repeating, 7th, 8th, 9th, 10th, 11th, 12th. All 12 years it is repeating uniformly or not? Yes, it is flowing uniformly. There is no gap in between. Starts from first year, goes up to 12 years, year end incomes without any gap, and hence I can straight away use N is equal to 12 there. Right? There is no problem for me. So this 56,000 is over. Okay, annual income of 55,60,000 is over. That is also done. What else remains now? Take one cash by one cash. There are so many cash flows here. First we considered P. Next we consider this cost 40,000. Next we consider this G of first cycle, that is 2000. Next we considered 5,60,000, which is the annual income for the entire 12 years. That is done. Which is remaining now? The salvage value of the first cycle. How much is it? 10,50,000. Where is it situated? At t is equal to 6. So that has to be converted into p is equal to 0. At t is equal to 0. Which factor I have to use? P by f comma 7 comma 6, because it is at a distance of 6 years from now. That has been converted. Put a tick mark. It is also done. What else remains now? This is not done. What is this? This is the second cycle's investment. How much? 30,50,000 minus, because it is negative. Where is it situated? At a distance of 6 years from now. Convert that into t is equal to 0 by using the factor p by f comma 7 comma 6. It is done. Put a tick mark. What else remains now? 2000 of second cycle. G of second cycle we have not yet considered. G of first cycle we have already converted. G of second cycle we have not yet converted. Consider that now. Using the factor p by g comma 7 comma 6. That's true because again count 1, 2, 3, 4, 5 G's are there plus the first payment. 5 plus 1, 6. So n will be 6 here. P by g comma 7 comma 6. But where will this p be situated? Will it be situated at t is equal to 0? No. Remember again, whenever you convert a or g into p, its p will be situated 1 year before the first payment. That is the rule. That rule cannot change. So where is it? Where is the first payment of the second cycle? It is at t is equal to 7. Where will its p be situated? Its p will be situated at t is equal to 0. T is equal to 6. So that has to be converted into t is equal to 0. Which factor I have to use? P by f comma 7 comma 6. Why n is equal to 6 there? Because it is at a distance of 6 years from now. Convert that. Okay. Second cycle's G is also over. Put a tick mark. What else remains? The last salvage value. That is the salvage value of the second cycle. How much is that? 10,50,000. Where is it situated? At t is equal to 12. So use the factor p by f comma 7 comma 12. Get the values from the factor tables, substitute them, and you will get the answer as plus 177,217. Now let us go to second machine. Factors values are given. Okay, convert them one by one. What is the lifespan of the second machine? 12 years. It is already 12 years. So there is no need for repetition. That's why it appears straight away 12 years. First alternative, it had a life of just 6 years. So I had to repeat it once again in order to make it as 12. It reached LCM. I stopped there. This one, there is no need for any repetition because it has already a lifespan of 12 years. Okay. Now let us take one by one. Initial purchase price of this much amount. Substitute that here. 40 lakhs. Substitute that here. At t is equal to 0. Annual operating cost of 55,000. There is only one cost component and hence it is A. Write that here. Cost component below the horizontal line. Annual revenue. Revenue is another word used for income. Okay. Sometimes they use the word income. Sometimes they use the word revenue. Both are one and the same. Okay. Revenue means what? Income. Income means what? Positive flow. Where it has to be represented? Above the horizontal line. Generated 6 lakhs at the end of first year, increasing by rupees 55,000. Again, there are two cost components. First year's cost component and the increasing component, which means it is a gradient flow. Represent that here. First year 40 lakhs. First year 6 lakhs and then increasing by rupees 5,000 every year till the end of its life, that is up to t is equal to 12. Salvage value at the end of 12th year is 10 lakh. Put it above this value. Useful life of 12 years. Done. Your cash flow diagram is ready. Okay. Now let us solve them. Let us use the factors and solve it. Write the given data first. PWB, that is present worth of the machine B, 40 lakhs minus 40 lakhs because it is negative, minus 55,000. It is, what is this 50,000? It is A. Convert that into P using the factor P by A comma 7 comma 12 because there are 12 flows. Next, 6 lakhs, the annual income, plus 6 lakhs because it is annual revenue or annual income. This 6 lakh flows continuously for 12 years for sure. This is the gradient. It increases by 2000, but base amount will remain the same. So convert that into P. Treat it as A and convert that into P with I is equal to 7 and N is equal to 12. So P is over, this cost is over, this A is over. What else remains? G remains, that 5,000. Use the factor 5,000 P by G comma 7 comma 12. So here again, how many G's are there? 11 G's are there plus the initial amount, 11 plus 1, 12, and hence 12. Where will this G be situated? 1 year before the first payment. That rule will not change. Where is the first payment? At T is equal to 1. So where will its P be situated? At T is equal to 0. What is our requirement? I need to convert every cash flow into T is equal to 0. That's why there is no need for any further conversion. P by G comma 7 comma 12 will bring this G into T is equal to 0. My job is done. What else remains? G is over, cost is over, initial payment is over, salvage value has not yet been considered. What is that salvage value? 10 lakh rupees. Where is it situated? At a distance of 12 years from now. What is it? Since it is a single payment situated at T is equal to 12, it has to be F. Convert that F into P using the factor P by F comma 7 comma 12. Substitute the values from the factor table. Get the answer. PWB is equal to 959525. Okay. So now write the answer conclusion. Which alternative is better? So that will end the first session on module